All right, welcome to the second video for section 5.2, where we're going to actually calculate a confidence interval for a proportion. And so we have some new players here and some information, probably not entirely new to you, but this E is the margin of error. And so the margin of error takes the critical value that we talked about in the last video and we multiply it by the standard error. And so that's p hat times q hat over n, and then the square root of all that. And so from an example, our p hat, and that's what we call this guy, don't know why it doesn't like it when I transition this. But p hat, that's going to be the proportion of successes from our data. So if we look at the example down below, it says in a recent poll, 180 people were asked if they like dogs, and 54% said they did. So 54% in this case would be the proportion of successes. But this is our sample proportion, and it's our point estimate. And then q hat is really the failures, and so for most of them it's just 1 minus p hat. And some texts just jump right to this. These are the failures. So we've got successes and failures, and n is our sample size, not new to us. And then the critical value, that's z alpha over 2. Again, not new to us. So, like I said, in the context of this one below here, we'll use those to find our margin of error. And in the context below, I'll scroll down a little bit, showing everything here we're going to do for the whole session. But in a recent poll, 180 people were asked if they like dogs. 54% said they did. Find the margin of error for this poll at the 95% confidence level. So some things I like to do is just write down what I have here. So our sample size is 180. Our proportion of successes, 0.54. That means q hat, 1 minus 0.54 equals 0. I have no idea what happened right there. But something happened, right? Technology. 0.46. And then we also know our confidence level is 95%. Which means our alpha is 0.05 and our alpha over 2, 0.025. So I'm going to actually jump over to Excel to finish this problem. At least that was my plan. So here we go. I think I can get Excel. And again, a lot of times with Excel, I do the same kind of thing here. Oftentimes I don't write the values here. In actual, I don't normally write the values there. I like to get them in here. But I'll write them here so we have it. Confidence level, 95%, probably could have abbreviated that. Alpha, 1 minus 0.95. And so I'm going to add a little bit of work here for you to see it. And then alpha over 2 is equal to 0.05 over 2. So those are the things we need, and so I'll get our critical value because that's important. This is old news, but we'll do the normal standard inverse, clicking on our alpha over 2 and putting that here. This is one of the conventional ones, and I think I'm going to adjust this to 0.025 just so that when I look at the work here, it shows up. I don't want you to worry there where that's coming from, but also that's kind of how I do the work. I just let it show up in here. And so this is all new. I mean, not new. The critical value is a little bit new. So now finding that margin of error, and that's really capital E, but I like to say M of E for margin of error because there's a little bit to do here. We need the standard error. And the standard error for the proportion was that value we had above. It's the square root of P hat times Q hat divided by N. And I do like to click on the cells. I know it makes the work a little bit less clear, but it makes it also very precise. So if I edit this here, this is 0.54 times 0.46 divided by 180. Those are the numbers that went in there. So you're going to see you have the standard error in the work there. Now, for the margin of error, I'm going to do the critical value, and I will just make it positive by doing -1 times the critical value and then multiplying by the standard error. And this gives us the margin of error. I like to do these without rounding them until the very end, but once I have the margin of error, then I get an upper bound. Well, actually, probably a lower bound is a better place to start. And then an upper bound for our confidence interval. And to find the lower one, we take our point estimate, P hat, and we subtract our margin of error. So this is, I'll say 0.54 minus 0.072809. Just double checking here. Yeah, I-12. And then similarly on the other side, we take the P hat and we add the margin of error. And so if I put this into numbers here, 0.072809. And a lot of these we round to 3 decimal places here, so 0.467 stays there kind of as a lower, and then 0.613 as an upper. So these are really my critical numbers along the way. So I'm going to take a little snip of this. Not my critical numbers, but I guess a lot of the numbers that I show here. And then jump back into OneNote. No, if it'll let me just paste this in here. There we go. So just give me a confidence interval. 0.467 comma 0.613. Sorry, that's a little bit smaller. And the confidence interval, that just kind of goes back from what we had and know. I'll make it a little bit bigger there for you to see. But that's our confidence interval. This is interval notation, so it opens at 0.467 and closes at 0.613. And then interpreting the confidence interval is something that we like to do in context here. And so oftentimes when we interpret, we estimate with blank confidence, blank percent confidence. We just insert our confidence level here. I don't know why I even picked the pen. Okay, there's a confidence that the true population, in this case, this is a proportion. This won't always stay the same. It will for proportions. But it's between here, the lower bound, 0.467, and the upper bound, 0.613. And I guess I filled out almost everything here except for the 95% confidence. So maybe I should just put that there. That's what the confidence interval actually means. We estimate with 95% confidence that the true population proportion is between 0.467 and 0.613. And we like to do that just so any rounding error and those kinds of things get sort of taken care of. But this is exactly what this means in the context of our problem. Now I wanted to do another example. It says assume that a sample is used to estimate a population proportion P. Find the 80% confidence interval for a sample of size 233 with 52.8% successes. And then here these are specific directions from WAMAP. Enter your answer as an open interval, parentheses using decimals, not percents, accurate to 3 decimal places. So I'm going to go ahead and just do this one in Excel. So I'll take a quick snip of the question and then jump back to Excel to show you how I would do the work here for the second one. And I wrote on the first one a little bit. This one I'm not going to as much here. I'll just put it here in typing. So we're going to find where a sample, assume that a sample is used to estimate a population proportion P. Find the 80% confidence interval. So our confidence level, 80%. For a sample of size 233, and I really just like to figure out what we have here. P hat is coming up 52.8%, so I'll enter that as a decimal. And then from that I can find Q hat. So equals 1 minus 0.528. Well, it would have been better if I put an 8 here. There we go. So, got that. A little bit of work there. Alpha. What's our alpha going to be in this case? Well, it's 1 minus 80%. 0.8 as a decimal. Put that here. And so then that little tail area, alpha over 2, gonna leave the decimal there. You're gonna have to trust me on this one. 0.2, nah, just kidding, I'll put it right here. 0.2 divided by 2. I expect you to show your work, so I will too. And all of that leads us to the critical value. Well, it's gonna lead us to more eventually, but for now, the critical value. Give us a little space. So normal, standard, inverse. I could click that, but I'm going to go ahead and just snag it here. This is this one, and this is a negative value. Again, we just sort of ignore the negative and we're going to have it be positive. Now, we're not always going to want to ignore the negative. I have such a hard time with it, I wrote it anyway. 8155. I like to just do these as precise as I can, and then let the error happen later. So we'll have the square root for our standard error. That's the next thing. Remember, it's P hat 0.528 times Q hat 0.472 divided by N, which is 233. And again, you can click on those if you want. I just like to have, I like to type them in here when I'm doing this. So that you can see where the stuff comes from. So now this is really our E, but it's our margin of error, which maybe it just makes a little more sense if I write that here. And the margin of error is going to be the critical value, Z alpha over 2, multiplied by the standard error. And again, we use this to find the lower and upper bounds for our confidence interval. And the lower bound, we take P hat and we subtract our margin of error. We're supposed to round to 3 decimal places. 4860, so that 6 is going to stay. And then for our upper bound, we take the P hat and add the margin of error. And .5699. So since it's 5, 6, 9 followed by a 9, that 9 goes up to a 10, so the 6 goes up to a 7. So here is one value, and here is the other value. And so we have here, I'm doing an interpretation here, 80% confident that the true population proportion is between 0.486 and 0.57. Now that's an interpretation, that's just a little bit extra. If I want to go back and actually answer the question here, we're supposed to enter this as an open interval. And so, okay, 0.486, comma, 0.57, and there it is. So, that marks the end of section 5.2, and so thank you for watching, good luck, and let me know if you have any questions.